Dear audience, dear colleagues, I see that students are working together in a team, that they're discussing the lectures, and that's very good. And that is actually how it's meant to be. I try to explain to you quickly, and then you are exploring by yourself. So, and also it's much more fun. And if you look at many discoveries, you will see two or even three names. So many scientists work together. And as a professor, as a student, if you're good, probably you want also good professors. And the same is with professors. We want good students. And I must say, I'm really proud if I have the best students. And yeah, if you ask me, the funny thing is that if I was the best in the class, actually no. I was one of the best, and I had enough average, 8.4, so that I could go directly on PhD in the cooperation with the company. But yes, I was good in math and physics, but learn by heart was not really my favorite, and there were some things I didn't like and was lazy. But however, you see, it changes. And yes, professors look for the best students because often they will come to good positions in the companies, and companies have money and need to do research. So from that aspect is also good. So I must say I'm really proud to have such students and also others with whom we are cooperating. I think it's going pretty good. So today, what we'll do, we will look at religion, and we will explore the beginnings of Hinduism, very interesting religion, and then follow some math where we will explore and give you the programs for 3D graphics. You will see, you will be able to rotate the graph. So, and also we will do symbolic calculations, so you will see the power of this computer. Because many of these programs were also made before by someone else, and why to do them again, we often use functions as you use some programs, some other programs as well. And then follows the story, and that will be it. So let's get started. And yes, for diploma I had a co-mentor, and he was a mathematician because I wanted some mathematician, and he was my friend. And he had average on mathematics, which is even harder, I suppose, 9.8 average, so really impressive. And he went to study in USA, then to post graduate study. So Hinduism is a grand, thousands of years old synthesis of different ancient cultures. When we go back before classic Hinduism, we find two main layers of spiritual life in ancient India, the Indus Valley Civilization and the Vedic Religion. Because of how far back they go, their creation myths range from mysterious archaeological puzzles to some of the most profound poetry ever written. The pre-Hindu religions of India, the Indus Valley Civilization, 3300 BCE to 1900 BCE. Long before the oldest Hindu scriptures were written, a highly advanced urban society thrived along the Indus River, modern-day Pakistan and northwest India. Because we still haven't deciphered their writing system, the Indus script, maybe we could do with AI. We can't read their prayers. However, archaeologists have dug up clues that strongly point to their spiritual beliefs. Thousands of clay figurines of women suggest they worshipped a fertility goddess associated with the earth and creation. The proto-Shiva Pashupati seals depict a horn-headed figure sitting in a cross-legged yoga posture, surrounded by wild animals. Many historians see this as an early ancestor to the Hindu god Shiva. Nature worship. They deeply revere piper trees, bulls, and water. They built a massive great bed in Mohenjo-daro used for ritual washing, similar as Romans did. The historical Vedic religion, 1500 to 500 BCE. Following the decline of the Indus Valley, pastoral Indo-Aryan tribes migrated to northwest India. They brought a religion centered around complex fire sacrifices and an entirely different pantheon of gods representing natural forces. like Indra, thunder, Agni, fire, and Varuna, cosmic order. Over centuries, these Vedic practices blended with the older Indus Valley and local traditions to form what we recognize today as a Hinduism. Is there a pre-Hindu myth of creation? Ancient texts offer a few incredibly fascinating perspectives of how the universe began. Cosmic sacrifice, the Purusha Sukta. The most famous literal creation myth in the Rig Veda, Mandala 10, Hymn 90, claims the universe was created through the sacrifice of Purusha, a cosmic thousand-headed giant who represented all matter. The god sacrificed Purusha, and from his severed body parts the world was built. His mind became the moon, his eyes became the sun, his brain became the wind. And the different classes of human society emerged from his mouth: arms, thighs, and feet. The ultimate cosmic doubt. While the sacrifice of the cosmic giant is a traditional myth, the Vedic people also wrote what is considered one of the most philosophical, beautiful creation hymns in human history, the Nasadiya Sukta. Instead of claiming to know exactly how a good God made the earth, it looks back at the absolute void before time began, admitting that the origins of existence are an ultimate mystery. And they said like this: there was neither non-existent existence nor existence then. There was neither the realm of space nor the sky which is beyond. What still? Where? In whose protection? Was there water, bottomless and deep? But after all, who knows and who can say whence it all came and how creation happened? The gods themselves are later than creation, so who knows truly whence it has arisen? The same question as we were asking: is there a beginning or is it infinite? The Vedas are absolutely the foundational holy text of Hinduism today. Over thousands of years, the ancient Vedic faith transformed so radically that historians give the early faith a distinct name: Vedism, or historical Vedic religion, to separate it from the Hinduism we see today. Now, around 500 BCE, India went through a massive cultural shake-up. Cities were growing and people started moving away from rural nomadic life. Men began to question the old Vedic fire sacrifices, which were expensive and strictly controlled by priests. This sparked a massive spiritual revolution. Two major things happened that gave birth to Hinduism as we know it. First, the internal revolution. Vedic thinkers began writing new philosophical texts called Upanishads. They didn't throw away the older Vedas, instead they reinterpreted them. They argued that the sacred fire shouldn't be a literal fire on an altar, but an internal fire of meditation. They introduced ideas of the immortal soul, Atman, and the ultimate universal reality, Brahman. Second, the external blending, the Hindu synthesis. As the Vedic culture spread further south and east into India, it collided and merged with the rich tapestry of local non-Vedic cultures, including the remnants of the old Indus Valley traditions and indigenous tribal religions. Local village goddesses were integrated as forms of the great Hindu deity. Tribal gods were identified as avatars, incarnations of Vedic or Puranic deities, like Vishnu. Hinduism shifted from outward sacrifices to inward devotion and evolved into the expansive, diverse spiritual ecosystem. Before the Upanishads, the ancient Vedic religion was all about outward action. If you wanted health, wealth, or a good afterlife, you hired priests to build a massive altar and cast offerings into a physical fire. It was a cosmic transaction. I give the gods food and the gods give me blessings. Like business, more economy-like. The Upanishads took that entire system and turned it completely inward. Instead of looking at the sky for gods, they told people to sit down, close their eyes, and look inside their own minds. The core big idea, Atman is Brahman. This is the ultimate breakthrough of the Upanishads. They introduced two revolutionary concepts that then argued they are actually the exact same thing. Atman, your deepest, truest self. Not your ego, your personality, or your thoughts, but the pure consciousness inside you. Brahman, the ultimate, infinite, unchanging reality that underlies the entire universe. The cosmic energy behind everything. The Upanishads dropped a philosophical bombshell. Your individual soul, Atman, is not separate from the cosmic universe, Brahman. You are the universe. Redefining the sacred fire, from ritual to meditation. The Upanishads didn't explicitly call the old priests liars, but they boldly reinterpreted what a sacrifice meant. They argued that throwing wood and water into a campfire was a lesser temporary fix. The true sacrifice, they said, happens inside you. Instead of an altar fire, use the fire of meditation. Instead of sacrificing animals, sacrifice your ego, your greed, and your desires. Quite good, I would say. Inventing the framework of human destiny. If you ever heard of the concept of karma or samsara, you have the Upanishads to thank. They link these ideas together into a coherent worldview that still defines Indian thoughts today. Samsara, the idea that life is an endless, exhausting cycle of birth, death, and rebirth. Karma, the universal law of cause and effect. Your moral choices determine the quality of your next life. Moksha, the ultimate goal. By meditating and realizing that your soul is one with the universe, you shatter the illusions of the world, break free from the cycle of rebirth, and achieve absolute liberation. By shifting the focus from appeasing external gods to understanding internal consciousness, the Upanishads created a highly psychological and philosophical religion. This environment of intense inward questioning is what paved the way for all later Indian schools of thought, including classical yoga, the philosophy of Advaita, Vedanta, non-dualism, and it heavily influenced the foundations of Buddhism and Jainism, which were born right on the heels of this philosophical revolution. Because Hinduism grew by absorbing so many different local cultures, philosophies, and regional traditions over thousands of years, it doesn't have a single pope or a single holy book that everyone follows. Instead, it is organized into major denominations or traditions based on which aspect of the divine a person focuses on. Hinduism is generally divided in four major varieties, denominations. Vaishnavism, the followers of Vishnu; Shaivism, the followers of Shiva; Shaktism, the followers of the goddess; Smartism, the liberal universal tradition. Because of this immense flexibility, it is often said that Hinduism is less of a rigid institution and more like an umbrella covering a massive family of interconnected faiths. So, welcome to Calculus 7. We continue with trigonometric functions, and sine minus 1 x is actually arc sine x, and this is not the same as sine x to the power of minus 1 in parentheses, and this is 1 divided by sine x, which is cosecant x. Now we have implicit differentiation. We met implicit functions already, and we would like f of x, which is y, is arc sine x, to differentiate this. And what we can do first is to put sine on both sides, and we get that sine y is x. And we actually already met this as well. So we differentiate it on both sides, and dx is 1. And when we differentiate by y, we get cosine y, and then we need to differentiate y as well. So dy dx is the same as 1. From here we express dy dx. And by the known identity from trigonometry, this is 1, and sine squared y is x squared, of course, because we have it here. And this means the cosine y is 1 minus x squared in square root. And with that, the derivation of arc sine x is 1 divided by this square root. And similarly, we get from arc cosine. Well, similar we get if we derive arc tangent, which is 1 divided by 1 plus x squared. And we will use this tangent of y is x, then secant squared of y times dy dx is 1, and use this identity, secant squared y is 1 plus tangent squared y. And similar we get for arc cotangent and cosecant not inverse, cosecant is this, you can see, and similar for secant, you get this. And now, let's do example. We want actually, we saw before that we have explicit form, implicit form, and parametric form. And the biggest form here is implicit. The most functions fall into this group. Then you have parametric, and then the most restricted, how to say, is explicit function. And let's say we have a function y squared plus sine of x times y is 2. And we would like to plot it, and we would like first and second derivative to be calculated, and that is exactly what we made together with AI for you. You will have a program, you will see it, and we use some predefined programs and libraries. And yes, here, when you will have the program I gave you, you can use also for Apple, but I think it has a different name. And it uses symbolic math, so you need to download this library, and for matplot library, something like this. I think you will get how to get it. And there you will see program. If you don't understand it, just paste it into AI and explain how exactly, why, and I will explain the theory behind this. So first what we do, we write this function as a surface, as an f of two variables now, x and y, and we simply put everything on one side, we get this, and this is the same as 0. And what is this? This is actually a function, this is z, and now instead of, in 2D we have x and then y, and now we have x and y and then z. And what this program does, it makes a grid of x and y, many points, I think 150 times 150 points. And for each this point, it puts inside the equation, you get f of x, y, and you get some surface, it looks like this. This is the surface for all this. And what program does, it checks when the graph goes from positive to negative. So where z is 0, then where z is 0, this is the curve we are looking for. And you will have everything on the image, and you can rotate it and zoom it. So I hope it will be fun for you that we use these tools. And yes, this is the general function. And then it uses symbolic calculation, and then you will have also other examples. And if you see one has really derivative, that I wouldn't solve it by hand because it's too boring. Okay. Well, how actually program calculates derivative? It uses actually partial differentiation, and this is a topic of multivariable calculus or multivariable chain rule. And we can see this normally taught in the second year on the engineering. We just look at the example. We have function of two variables, x and y, which is x to the power of n times y to the power of n. And partial, this time like this, we can write fx, subscript is f partial to x, and what we do is simply, we treat y as a constant, and we derive there where is x. So we get n times x to the power of n minus 1 times y. And similar for y, we treat x as a constant, and we derive only y. Now the second derivative, fxx, is then, again, double derivative x and n, and similar to double derivative of y. And the mixed derivative, f of x and y, is actually the same as f of y to x. It always works like this, and is nm times x to the power m minus 1 times y to the power of m minus 1. And for our example, df dx is now, we derive f partial to x, and then dx of dx, you see x's are cancelling out, and this is 1, and then f partial to y times dy dx, and we get fx plus fy dy dx, and from that expression dy dx is minus f partial x divided by f partial y. And for second derivative, we do the same precision once more. We get this square y dx square is this, again to x, to y, and don't forget to put here dy dx once again, and with f notation is this. Rearranging, you will get the following result, and if we return to our example, the derivative, second derivative is this, which will be shown in the program as well. So, our final example is Lemniscate of Bernoulli, and we will start with parametric form, then we will derive also all other forms. And parametric equation x, now parameter phi, is a times cosine phi divided by 1 plus sine squared phi. And y phi is a times sine phi cosine phi divided by the same thing. And it looks like this. If you will plot it, you will get there, it looks like 8 turned around, or symbol for infinity. And this is 45 degrees. And a is here, minus a is here. So this is how it looks, and what we will be searching first derivative, and we will equate this first derivative with 0, and this means that we will search, at that time the derivative is horizontal line, and we will get those 4 points where they are. And how we do this, dy dx is actually, we write dy divided by d phi and dx divided by d phi, because d phi actually cancels out. And we will search when this is 0. So dx d phi, actually we wouldn't even need to calculate it, because we need only dy when we are equating with 0. But anyway, for practice, and you should do it by yourself to check if it's correct, you will get this expression, and you simplify it, a times sine phi times 3 minus sine squared phi in brackets, divided by the same thing squared, and dy d phi, you will get this. Now I'll set equating this with 0, you will get 2 times cosine squared phi minus 1 minus in brackets 1 minus cosine squared phi, which is sine squared phi, of course, times cosine squared phi. Rearranging this, you get this equation, and we recognize here actually quadratic equation, where instead of x is cosine squared phi. Cosine squared phi, and you use the well-known formula, you get this, and this is minus 1 plus square root of 5 divided by 2. And this is actually golden ratio conjugate. Now, we can write sine squared phi is 1 minus this, what we get, and rearranging we get this. So 1 plus sine squared phi, you get this. And inserting them in equation, just squaring the equation, x squared is this thing, and this, when you will perform the calculation with all these square roots and rearranging them, you will get s squared 1 plus square root of 5 divided by 10, and calculating x, you will get this result, 0.5688. And similar for y squared is this, inserting these square roots and calculating, you will get that y is this thing. And here is one interesting catch. I didn't know about this, and I think it must be true. And as I said also this, if you do this on test, I will give you all points, no problem, very good. But it will turn out that it's slightly different result as in all other cases, which we will see in the moment. And to show this is different, we can write y as using trigonometric identity, 1/2 of sine 2 phi divided by 1 plus sine squared phi. And dy d phi, you derive it, you get this, and after a tedious calculation, you can now use this simple math if you will learn, and to check, to verify your result, you just symbolically derive and then simplify the result. You get 1 minus 3 sine squared phi is 0, which means that sine phi is 1 divided by square root of 3. And cosine squared phi is 1 minus then 1 minus 1/3, which is 2/3. And from that, cosine phi is plus minus square root of 2 divided by 3. And with that, we get x is plus minus a, what you see here, and this is 0.612, and before we have 0.57, something like that. So I think approximately 10% of the difference, but this one, why you get similar, is almost the same. So I don't know what exactly happened. Maybe this would be one diploma to research this, but this is more correct, although both are correct. So strange things are happening in mathematics. And why are they plus minus? Because we have 4 points. One's there on one side, the other, and so you can imagine that. And now the second is Cartesian coordinates implicit form, and if we write x squared plus y squared from those which we had before, you get this expression, and x squared minus y squared, you get this expression. And you can see that if you square this, they became almost the same. No, almost. I mean, they become the same. Further on, so the square of one function is the same as the other, and for our program which you have, you write f of x of y is this, and it's the same as 0, crosses the x's, and deriving this implicitly, you get this expression, and expressing dy dx, you will get this, which means that this must be 0, so x squared plus y squared is x squared half, which we know is a circle. And inserting this back into the equation, we get another one, and this, and now you rearrange this, and once we sum them, once we subtract them, we get two expressions, and from there follows x and y, which are the same as in previous case. Further on, we introduce polar coordinates, and what it's all about, instead of x, y, we want to have r and angle phi. And from the picture, you see that x squared plus y squared, according to Pythagoras, is r squared, and tangent of phi is y divided by x. Pretty simple. And these important relations, x is r times cosine phi, and y is r times sine phi, which you can see from the picture. So this is the transformation. And now, returning to our example, we insert these formulas for x and y into equation, and we get this. We're using trigonometric identity transform to this, so we get the polar form of our function f squared is a squared times cosine 2 phi. And now we derive it implicitly again, and 2r is dr d phi is minus 2i sine 2 phi, expressing dr d phi, and again dy dx, as we had before, we put on two terms here, and deriving you get this, and now you insert dr d phi from here where we calculated, and you get this. Again, inserting our polar equation into the derivative, we get this, and using some special trigonometric functions, this simplifies to cotangent 3 phi, which is 0. So that means that cosine 3 phi is 0, and that happens when phi is plus minus p divided by 6, or plus minus 5 p divided by 6. And inserting this, the first one, into our equation, we get this, cosine p thirds is a squared half, and from that we get that r is a divided by square root of 2, and from that simply follows x, cosine b6 is the same as before, and for y we get also the same as before, and then using this angle, you will get here minuses, so again we get all 4 points. And now final form, you see, we already said that not all implicit functions can be written in an explicit form, while vice versa is correct. So this function actually has an explicit form, and we expand the equation for implicit form. We expand it, and rearranging, we get y to the power 4 plus this y to the power 2, and we see here again the quadratic equation, and solution for quadratic equation is as follows. Y squared is then this, and y is plus minus this into the square root, which is the same as to the power of 1/2, and dy dx is the derivation 1 divided by 2y dx, this is what is inside the bracket. Calculating this, you get this expression and simplify it, which must be the same as 0, and from this follows the simple equation from which we get x and y, and they are the same as in all cases before. So that would be it from mathematics side. Hope it was alright, it was useful. And now follows the story, which was inspired by the events in our country. So I hope you enjoyed that too. Dear colleagues, thank you for your attention and have a nice day. Here again. Ja, snimam. Bel golob. Ja, pa se, zdaj snimam ga.
A ti ga snimaš,
Ja,
se mi
on je ta glaven, glej. Vsi mu sledijo. Deep within the whispering woods, the air smelled of damp earth, pine needles, and anticipation. The annual mushroom festival was only hours away, and the forest was alive with preparation. Squirrels were busy polishing bioluminescence caps to use as lanterns, while badgers arranged tiers of rare truffles. The undisputed stars of the evening, however, were eagle and falcon. With their majestic wings and flawless coordination, they were set to perform the opening aerial dance, cutting through the canopy like streaks of gold and silver. Everyone was thrilled. Well, almost everyone. Tucked away under a gnarled oak root, Barnaby the rabbit gnawed on a bitter root, his fluffy tail twitching with pure envy. He muttered, glaring up at eagle and falcon.
Look at them, just because they can fly, they get all the glory. I'm the best worker in the woods, relegated to mushroom sorting.
Jealousy quickly turned to malice. Barnaby didn't just want to skip the festival, he wanted to destroy it. Over the past week, he had secretly gathered dried spore bombs, highly volatile, explosive fungi that, when crushed, released a blinding, concussive blast of smoke and fire. He packed them into a massive sack, planning to detonate them right beneath the main stage. As twilight fell, the forest illuminated in brilliant shades of neon blue and violet. The animals gathered, cheering as eagle and falcon took to the sky, spiraling perfectly. Barnaby crept through the shadows, dragging his heavy sack toward the stage. He reached the main route, pulled out a flint stone, and raised it to spark the fuse.
Not so fast, Barnaby. We've seen everything. You've been acting suspiciously.
Before the stone could strike, a shadow fell over him. Barnaby looked up into the piercing eyes of Falcon, who had spotted the strange rustling from above. Eagle descended a second later, landing with a heavy thud that pinned the sack of spore bombs to the ground. The evidence: a sack of 50 highly explosive spore bombs. The motive: pure, unadulterated jealousy. The catch: caught red-handed by the festival's guests of honor. The festival came to a halt as the animals gathered around the traitor. A terrorist attack on their beloved mushroom celebration was unthinkable. The owl elder stepped forward, looking down at the trembling rabbit.
Barnaby of the Whispering Woods, you sought to bring fire and ruin to our peace. The skies saw your malice, and the earth rejects your actions. You shall keep your life, but you will need to take a medicine every day, a dose of antipsychotic mushrooms, and you will be under constant surveillance.
Barnaby didn't fully understand his actions, but mushrooms had a positive effect. He became better at judging what is right from wrong and that doing harm has consequences. He lost his job as a sorter, to which he was so proud of, but he found himself happy in a new job as a waiter.
The drink of the day is mushroom cola. Who wants this specialty of magical forest? Drink and eat, my friends. There's more to come.